Okay, we start calculus with the first review. Section 1.1 is on page 10, talks about 4 ways to represent a function. So here we're going to focus on functions because calculus, especially the first semester, focuses on functions more than anything else. And I have to remind you a few things. Keep in mind what they did here in this section and the next section. They took certain topics, actually not certain, a lot of topics from algebra, and they embedded all in a couple of sections. So it's kind of condensed with information. You need to weed your way out of it, but this is like the bare minimum of what you need to kind of survive in this class. Starts off, they start with a difference quotient formula that you saw in college algebra. Well, given f of x equal x cubed, find f of a plus x minus f of a over h. We'll talk about what that means later on. For now, we just want to play with the mechanics of this a bit. F of a plus h turns out to be a plus h cubed, and that is a cubed plus 3a squared h plus 3ah squared plus h cubed. So if I substitute accordingly what each of those are, this first piece would be a cubed plus 3a squared h plus 3a squared h, 3a h squared plus h cubed minus, if I look at what f of a is, well, f of a is simply, wherever you see an x, replace an a, that's a cubed, all over this h. So if I clean this up, this is a cubed plus 3a squared h plus 3a h squared plus h cubed minus a cubed all over h. I notice those cancel out. And I would say that is 3a squared h plus 3ah squared plus h cubed divided by h. If I factor an h out, 3a squared plus 3ah plus h squared all over h, and I would be left with simply 3a squared plus 3ah plus h squared, and that would be my final answer. As you see, I'm working downwards, and if I need to use the other side of the page, I put an arrow. You're going to do the same on your homework and especially in your exams so I can follow your work. The second example I'm looking at would be a rational function. So for functions, you're going to see more than anything. You're going to see rationals, radicals, polynomials, and trig. Trig, not as much in this class, a lot more in the next semester. So if I want to figure out what f of x minus f of a over x minus a is, well, f of x is simply what I see, minus f of 1. Wherever I see an x, I replace that by a 1, over x minus 1. This would be a complex fraction. The LCD for the top and the bottom combined would be 2 into x plus 1. To simplify a complex fraction, you make sure all the denominators have it. So what's this missing is a 2. Multiply top and bottom by 2. What's this missing is an x plus 1. Multiply top and bottom by x plus 1. And what's this missing is a 2 into x plus 1. Multiply top and bottom by that. And once you do that, when you multiply by the reciprocal, since the denominator is the same, those are going to cancel out. I would be getting a 2x plus 6. This is a 4 minus 4x and a minus 4 all over 2, and the denominator I really don't touch. That would be 2x squared minus 4x is negative 2x plus 2 divided by, and the denominator we don't touch, if I factor a negative 2 out of the top, that would be x minus 1. And when I get to the calculus part, I'll give you a few hints of what must happen. And there's my final answer. So, the next set of problems talks about domain. So again, they're picking all of these different topics. Let's get this out of the way. If I see, and domain is going to come up in the same type of functions. Rational, polynomials every now and then, radicals, and trig. Well, if I see a fraction, I take the denominator and figure out where does that equal 0, because that's the only exception. That's x plus 3 into x minus 2. So I know that x plus 3 should never equal 0, and x minus 2 should never equal 0. X should never equal a negative 3 or a 2. So if you want to find the domain, you could say domain is choose an x such that x can never equal those two values. That's an acceptable answer. Or not recommended. Oh boy, I messed up. Or not recommended, but you could use interval notation. You should use interval notation when you have multiple conditions, or when you have an interval. You could say negative infinity to negative 3, union with negative 3 to 2, union with 2 to infinity. If you really want, that's also accepted. When I have multiple conditions, I would work those individually, and a number line should do the trick. It doesn't matter whether you're adding those or subtracting those. So what you do, you look at a number line and pretty much figure out how that works from there. Radicals, unless they appear in the denominator, we want the radicand, the quantity underneath the radical, to always be bigger than or equal to 0. So if I solve this, this says negative t is less than or equal, is bigger than. I moved the wrong thing. This says t is less than or equal to 3. So if I go ahead, go to 3, include that, and say x is less, or t is less than, assuming that's t. And if I take this and say, well, here we want 2 plus t to be bigger than or equal to 0, we want t to be bigger than or equal to negative 2. Negative 2 is to the left, included. And if I take this and say, well, anytime I have multiple restrictions on a domain, anytime, it's always and. And and means an overlap. When I overlap the yellow with the, I forgot what that's called. Let's get the blue. I'll get the region that satisfies both. So my solution is negative 2 to 3. That would be my domain. So when you're dealing with an interval, it's a good idea to use interval notation. Otherwise, you should stick with set notation, but you could use whatever you want. A function that's never going to leave you alone, and students seem to suffer with this for a great time because they misunderstood the definition. I'm going to elaborate on that. Let's talk about that. Absolute value. Absolute value is always positive or 0. If you see that symbol, you should know this side is either 0 or it's positive. It can never be negative. The principal radical, if you have an index that is even on a radical, square root, fourth root, sixth root, the outcome is always positive or 0. It matches. This seems to give students a heck of a time. Let me elaborate really quick. If I say we are looking at the square root of 16, this is asking, a radical is asking, what do you multiply by itself to get a 16? The answer is positive 4. 4 times 4 is 16. Or negative 4. Negative 4 times negative 4 is positive 16. The fact that we set the principal radical to always be positive eliminates the negative out and says that's not allowed. So if somebody was to say, what do you multiply by itself to get 16? The answer is positive 4 or negative 4. If I was to look at the square root of a squared, what do you multiply by itself to get a squared? The answer is a. Well, not really, because what's a? A variable. variable means it could vary, it could change. Could this be negative? Can't I say a squared is 16? Right? And a could be a positive 4 or a negative 4. Since this could be negative, to ensure it's positive, I know of one function that guarantees a value is always positive. And again, this is really, if you would have had me for algebra, I would have spent an entire section on this. For now, this is how we're going to see things for most of the time. We have x squared equals 16. I want to elaborate on that, not for the answer. I need you guys to understand the concept, because the concept of absolute value is not going anywhere. If I look at the right side, student side right plus or minus 4. Actually, it's plus 4. They're mistaken. You could write plus or minus 4. I don't mind, but that's not how you get it. I'm after how you get the answer. The left side is x, almost. Couldn't this variable be negative? Now that equation is correct. Now when you take the absolute value and split it up, x yields a plus or minus 4. The plus or minus really arises from the left side, not the right side. I don't mind at all you seeing x squared equals 16. You square root and say x equal plus or minus 4. That's fine. I'm just, again, we're not after the answer. Absolute value is something you're going to have to tackle a lot more than you like, and I need you to get that out of the way. And this doesn't only work with equations, it works with graphs. I want to show you something. The graph of y equal absolute value of x. Let me elaborate, and again, we're going to see more things that you saw in algebra. Unless you took me for college algebra, probably this is the first time you've seen this. Because, you know, that's not required. I cover it normally because I know STEM students are going to see this. Look how we're going to start graphing. We're going to ignore the absolute value. We're going to say y equal x. There's y equal x. Very simple. When you slap an absolute value, we're going to say, now look, y equal an absolute value, which means it's always positive or 0. Well, positive right there. Do you see that y is positive, right, negative right there? So what you're going to do, you're going to reflect that. And the graph is going to look like, again, I need you to understand this concept. I'm not after you redoing everything that you did. I need you to learn new tricks. So if I want to sketch a graph of y equal absolute value of x plus 2, I am aware you know how to graph that. Just entertain me for a bit, just a bit. So, can you sketch a graph of y equal x plus 2? That's a line with a slope of 1. So that's kind of how the graph looked like. This is way out of sync. Let me just line it up properly. There we go. Okay, much better. And now, when you say I'm putting the absolute value on it, you'll say, well, okay, wherever it's negative, you're going to reflect that. And the actual graph looks like this. Again, nobody's saying you have to do that on a problem like this. But when I get to this problem now, that I know how to graph absolute value, I know how to graph this. That graph is a parabola shifted down 1, 2, let's say this is negative 2, this is negative 4, and this is 2, 4, this is negative 2, negative 4. The graph looks something like this. So I'm not showing you how to graph an absolute value in this section. I'm teaching you how to graph all absolute values, every single one of them. What happened if I put an absolute value on it now? Y equal an absolute value, that means y is positive. Where's y negative? This part is going to reflect, and the graph now looks like this. Oops. Alright. Okay, I'm going to stop here and do the next problem on the next section. The next video, I mean.